And you and Izzy can split. And you guys can see for yourself as to whether or not you understand the idea, first of all. And then number two, whether you might want to use the idea for something like a 3x3 or a 4x4 or a 5x5, and if it would save any work. Maybe it will, maybe it won't. We're just checking it out. It's a way of using matrices. Okay, so here you go. Kramer's rule says, take the coefficients of the variables. Take the coefficients of the variables. Take the coefficients of the.
Oh shoot!
I didn't see that.
This dude.
You fool, Jay, you fool.
So close.
Not near as bad as my algebra book. Okay, so.
Oh my gosh.
Algebra.
Where is it?
Check it. Can you guys tell? Can you guys tell?
This is all just hanging off back here.
Can you guys tell how to make the numerators? Okay, hold on. Okay, so we have A and B, no big deal. We're taking the coefficients, denominator. Coefficients, denominator. Got it. But what happens in the numerator? Yeah. Check it. If I want X, ooh, I didn't even write it. I'm sorry. If I want X, I take out the X's and put in the C's. If I want Y, I take out the Y's and I put in the C's. Do you see it? So check it. I want X. I'm going to take out the X's and put in the C. 10, 11, -2, -5. I want the Y's. I'm going to take out the Y's and put in the C and keep the X's. Now maybe you're like, okay, I could have done substitution. I could have done elimination. What the heck? But check it. Isn't this just a simple main minus opposite now? Okay. I have -50 minus -22, aka -50 plus 22, aka -28. This one I have 44 minus 30. That's going to be 14. In the denominator, I just have to do one determinant because they're going to be the exact same thing. The denominator is always whatever the determinant is of the variable coefficient. So I have -20 minus -6 or -20 plus 6. That's going to be, so x is equal to 2, y is equal to -1. Doesn't seem that snazzy in this example because it's like it was a nice answer. I bet substitution or elimination would have been just fun. I bet it would have been just fun. However, have you ever solved a system and gotten kind of nasty? Kind of difficult? Answers? Oh, again? Yeah. Just go straight back by the fridge and
In the fridge?
by the fridge.
Okay.
So if it was kind of a nasty system, maybe it would save time. Maybe it wouldn't. Maybe it would. So there is a formula. I mean, it's a thing. I don't really know if you need to write down the thing. That's why I was trying to solve an example fairly quickly. What you're ultimately doing is you're asking yourself, what variable am I solving for? Whatever variable I'm solving for, this guy, that's where the C's go. Whatever variable I'm solving for, that's where the C's go. And the denominator always stays the same. So in some ways, I mean, maybe write everything down, but in some ways, maybe it's not that big a deal. Just realize where the C's go. So the question is, would it make a 3x3 easier? Would it make a 4x4 easier? If I have a 2x2, two variables, two equations, I'm going to have little baby 2x2s that I'm solving determinants for. Those are easy. But if I have a 3x3, don't I have 3 different 3x3 determinants to find? That sounds kind of hard, yeah? 4x4, I'd have 3 different 4x4 determinants to find. Like, I'm not sure it would necessarily be easier, but it is an alternate way. So I technically have a 3x3 over here just chilling. I just want to make sure that you guys understand the idea, like how to set up solving the 3x3. So we'll do the setup of the 3x3, but then let me give you a 2x2. That's maybe not super gorgeous, and we'll see if you guys can beat me using substitution or elimination. Unless you wanted to matrices and Kramer's rule with me. Or I guess you could do RREF also. You could do substitution, elimination, row reducing, or Kramer's rule. And we'll see who wins. But first, let's see if you guys can set up a 3x3. Using Kramer's rule. Oh, one more page over, sorry. How would you set it up? How would you set it up? You don't necessarily need to write the whole thing down, but think through how could you apply Kramer's rule for doing a 3x3? Uh-oh, is your pencil back here? Let's see. Oh, you're good. You guys are just seeing if you know how the rule works before we do the contest of solving a 2x2. Okay, comparing your groups so fast. Did you plug it in right?
I'm ready.
Okay, have a good 2x2 to use for our example.
Yeah, I'm very confused. I'm kind of lost. Yeah, but like.
Kramer's rule is just an alternate way of solving. So we have an x and a y and a z that we're trying to find, hence why I have 3 different fractions. All of their denominators will be the exact same in that all of their denominators use the coefficients of the variables, aka determinants. But the numerators will all change because the process of the system, the application, the rule, is that whatever variable you're solving for, his column gets eliminated.
Oh.
Which is why I'm going to go ahead and say, you know what? For this first guy, the y's, oh, no, not the x's. They're the ones that need to leave. The y's, they were allowed to stay. The z's, they were allowed to stay. But who needed to change were the x's, because I'm going to solve for x first. So I needed negative 14, 10, and 1 to take the place of the x's and where the x's were. Now in the next one, hold on, where's the negative 14, 10, 1 going to go? I can bring the x's down. I can bring the z's. Oh, not that guy. I can bring the z's down. But who's going to go in the middle is my negative 14, 10, 1 for my y variable. Because all the y's need to be gone and be replaced with the x's. Sorry, the solutions, the c's. Although technically A, B, C, those would probably be d's. And then what's going to happen to make my z? Keep the x's, keep the y's, but replace the z's. To be negative 14, 10, 1. I'm not going to make you guys necessarily go do all those determinants, but check it. How many determinants would you actually need to be solving for? Nope. What's true about? Yeah, just 4, because all 3 of these are the same. So you would go ahead and, well, hold on. I wonder if you would solve for this guy first, just to see whether or not this is singular, because if there's no inverse, or I should say, if the determinant is maybe like a 0, I might be in trouble, and it might be one of those no solution ones that I don't even have to worry about. So we would always go tackling the denominator first, because if the denominator, if this guy is 0, well, forget it. You're done. It's no solution. No problem. But yeah, we would solve for this guy first. We would have a denominator, then we could solve for each of these. Now, to prove my point that maybe this is sometimes easier. Maybe. I'm not saying you have to use Cramer's rule on a test. If I was to make it like a multiple choice, you could probably double check it with elimination or substitution or matrices. I would probably just ask you to set up the formula and show me that you know how it works, rather than necessarily making you use it. But check it. I'm going to give you a 2x2, an XY system. And you're going to write it down. I'm going to give you like 15 seconds to write it down. And we're just going to solve it whatever way you want. Substitution? Sure. Elimination? Sure. Matrices with row reducing? Sure. Cramer's rule? Sure. But hold on. No one starts until we're all ready. Write it down. I'm going to use Cramer's rule. Don't start it. Write it down. Choose what method you're going to do. Substitution? Elimination? Cramer's rule? Making it a matrix and row reducing? You guys ready? You saw it already, little cheaters. Write it down. On your marks, get set, go. You guys got it?
What?
I got Y.
I haven't even got a Y
I
yet.
got the problem.
How was Cramer's rule?
Hey, bro, stop saying that word.
Now, let me double check. 35 minus 6, maybe I didn't. That was perfect. 29. And then I put my 7-1 in my 5-2 spot. I put my 7-1 in my 3-7 spot. And 49 minus 3 is 46. And 5 minus 14 is negative 9. Look at all those little baby addition, subtraction, multiplications. Look how easily I got to a nasty solution. So does Cramer's rule make an easy system harder? Yeah. But does it make a hard system easier?
No.
I don't know. I think I beat almost everything.
We should have one more.
One more? You like the idea of it, huh? You guys want to practice one more time?
You should be looking at it. It's not there.
Did you beat me, Chi?
No.
You're going to eliminate D?
I don't think I'm allowed to.
Yeah, probably not. It's probably a bad idea. Probably shouldn't eliminate Chi.
I think she wants to eliminate these with you. So,
Okay, someone give me a number.
Why so high, Emily?
42.
Someone give me another number.
1.
0.
1.
0. Negative 3.
0. Not 0. Negative what?
42.
3.
2. I think we should go with a solid.
Okay, you guys ready?
11.
Okay, don't start solving until we all start. Here we go. I just put them in random orders. Write down the problem. I'll wait until you guys have it all written down. No cheating. This one's a little easier because one's a negative, one's a fine. Get it written down. Choose which way you want to go. Substitution, elimination, matrices, Cramer's.
On the test, would you like use Cramer's rule, or could you use?
I would ask it on one problem, kind of like last test elimination was asked or row echelon was asked. But technically you could like set it up with the formula and then solve it your own way and be like, I did it. Think, think. But I just want to be able to see that you know how to plug it in. Is it written down?
Yeah.
And your marks are set? Go. You guys all try to beat me in my own game. 1 can reduce? That's no fun.
Bro, relax.
Does it match? Well, double check. Hold on, am I doing it wrong? 10 minus negative 30 is 10. Oh no, it was 10 minus 30. Ah, you guys might have beat me. Struggle. It was negative 20.
Okay.
Lo siento.
I did not. Wait, what?
So it's, is it negative 9?
There you go. Is that better?
Yeah.
I even thought it in my head, and I was like, what? 5 minus 30, or sorry, 10 minus 30 was negative 20. That was my denominator for both. And then I went ahead and ended up with 8 minus negative 10 is 18, and 5 minus negative 12 is 17. Dun, 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 dun. I reduced. Who beat me? That time.
She.
Priyanka. Anybody else? Sophia did? Nice. Anyway, Cramer's rule. It's nifty, especially for nasty systems that have yucky fractions. You'd be like, forget it, I'm just going to do Cramer's. But to be honest, I don't know if it's necessarily like the best way for us to solve. Who wants to do 4 different 3x3s? No, thank you. Especially after homework last night with all the determinants. Okay, another application. What if I was to give you something like this? I'm going to show you the application, then you can write down what you need as far as the formula. Okay? Here's a triangle with points or vertices at 3 different points. And it just says find the area. Now, hold on. Okay, area. 1/2 base times height. Easy. But I need the height. And I need the base. Oh, bummer. Distance formula, and then find the midpoint, and then distance formula, and 1/2 base times bleh. Could do it. Oh, law of sines. 1/2 side included angle. Well, I guess I could do distance formula. There's one side. Distance formula, there's another side. How do I find that angle again? Maybe the third side, law of cosine? Maybe Heron's formula. Hero's formula, side, and then use, or just use a matrix. Because the matrix says, as long as you know the plus or minus, we'll figure out in just a second. It's actually more of a question mark until the very end. It's 1/2 times, all you gotta do is just take your 3 points in any order, fill in a column of 1s to make this a 3x3, and then just find the determinant. Remember, applications of determinants. So determinants, I could go ahead and say, well, hold on, it's a 3x3, so good review. We gotta choose any row, any column. That's a positive, negative, positive.
The 4, 3, 1.
And I'm gonna do my, yeah. I was gonna do the 1, 0, 1 because there's a 0. But yeah, you could do any of them. You could do 4, 3, 1 or 1, 1, 1. And I'm gonna choose my minors, my cofactors. Remember, just tell me what sign to put in front. That's a minus, and then there's 0. That's just 0. And then I have my 2, 2, 4, 3. I have a big old 1/2 being multiplied in front, and I have this weird plus or minus question mark thing. When I go ahead and do main minus opposite, 2 minus 3 is negative 1, minus 0 goes away, times 1, that's good. And then 6 minus 8 is negative 2, times a positive 1, that's good. And then I have a little 1/2 a chillin', and I have this plus minus question mark thing. This ends up being negative 3 over 2. But guys, is area ever supposed to be negative? Since it's not supposed to be negative, this little question mark was like, hey, area is not allowed to be negative, so put a sign in front that makes sure he stays positive. They couldn't just put an absolute value in the beginning because absolute value in matrices means determinant. So they instead in the formula put this little plus minus as just a little way of saying if you have a negative answer, just make it positive at the end. Choose the negative times a negative and say, okay, I get it. The area is that number, but the positive of it. What did I do? I took my 3 points in any order. I put in the first, second, third, or the second, third, first, or whatever you want to choose. Put them in any order. Fill in the 3x3 with this whole column of 1s. And then choose any row, any column to solve your determinant. Just a, I don't know, snazzy application of determinants. Just a snazzy application of World War II. Snazzy application of determinants. to find area without Hurons, without log cosines, and without lots of baby distance formulas. That's interesting. Oral, did you have a question? No, you don't. Okay, so write down what you need. Maybe you need all of it, maybe you need none of it. But basically, I'm just putting in all 3 points that make up a triangle, once, a 1/2, and then just make the answer positive at the end if it's not. That's that whole weird plus or minus. Okay, so we did the whole Kramer's rule. Craziness sometimes might be nice, sometimes might be harder than it's worth. Area, okay, it's an alternative way. How does area help us with collinear? I have a picture of 3 points, and these are the 3-point weight. It's like I'm doing the area triangle thing, except, hold on. It's kind of like a triangle, except there's no 1/2 in front. Guys, if I was talking about area of a triangle, there would have been like a plus or minus 1/2 here. What's going to happen if I go to do a triangle and I end up with an area of 0?
It's not actually a triangle.
It's not an actual triangle, and the only way that 3 points can't be a triangle is if they are on the exact same line. What does collinear mean?
Same line.
On the same line. With or together, linear, on the same line. So here's the idea. Even though there is, I know, there's a whole formula, but basically what it's saying is, hey, if the area, if you go to do area and it's ever 0, well, then it's not a triangle, so they're collinear. So I stole these 3 points, pretended as though I was doing area. You can even put the plus or minus 1/2. If they're ever asking you for whether or not they're collinear, try to do area and see if it becomes 0. If it is, then yes, they are. If it doesn't, there's a number. Oh, nope, that could have made a triangle. They must not be on the same line. I see lots of 1-1-1s. I'll choose these guys. You can actually ignore that little 1/2 because all I'm asking myself is whether or not they are collinear. So I just need to know, are you 0 or are you not? If you're 0, yes. If you're not, okay, fine, no. So plus minus plus with my little minors. And then minus another 1 with his little minors. And then the last little one with his little minors. Uh-oh. All I need to know is this is going to be a 0 or not. I have 5 minus 7, which is negative 2 times a 1, minus negative, oh, thanks. 1, yeah, instead of 7. Negative 10 minus negative plus 14, which will be 4. And then plus negative 2 minus negative 2, which is 0. That's 0! Oh, but that's not 0. Not 0, meaning non-collinear. Can I actually make that a thing? It makes a triangle. If it makes a triangle, it's not in the same line, so forget that. So basically, this is just an extra application. If you go to do area and it's 0, then they're collinear. And if you go to do area and it's not 0, then they're not collinear. Basically what's going on there. So we've talked about Kramer's. We've talked about area. Area kind of tells us about collinear. Wow, so many applications of woo-hoo-hoo-hoo-hoo. And now coded messages. Last application. Last application. Last application. Coded matrices. Or I should say coded messages using matrices. The matrices aren't coded. The messages are coded. With matrices. Now, you could write out the entire alphabet with 0 through 26. You could. Do you necessarily need to? On the test, I'm going to put a picture of the alphabet up on the screen. So if I were you, I'd take a picture of it right now. Be like, okay, there's the alphabet. I can use it. I can refer to it. It's in the book too if you need it. I don't know if you need to write out the whole alphabet, but the steps might be helpful. Cryptograms are just coded messages. Well, I guess technically coded or decoded, but it's the idea of secret messages trying to hide messages. Cryptography, the study of Encryption. Online banking information. Encryption. Crypt. You guys have heard these words before. Yeah. Go on.
So doesn't every number just associated with like the thing? So can't you just like fill it out?
Well, here's the problem. What if this is what was given to you? Now, it won't be given to you like this. As soon as it's given to you in a matrix, there's actually already a hint as to where it came from. But what if you were just given 13, negative 26, 21, 33, negative 53, negative 12, like a string of numbers? Why is this a lot more hidden?
Because with that one, it's all in a line.
It's 0 to 26. Like, where are the negatives coming from? I don't understand. But this actually came from this message being multiplied by this matrix. If you were to look at a string of these numbers, you would say, like, okay, I see a couple of different zeros. I see a couple different 5s. I bet 5s go with E. Oh, hey, A, B, C, D, E. Oh, that makes sense. And then it only goes up to like 26. Okay, cool. Hey, A is 1, B is 2. Write it out, match it up. If you just saw this string of numbers, people that are pretty good at just playing with numbers would figure out very quickly, oh, they just did the simple, like A is 1, B is 2, C is 3. However, if we take this message, where we can see like E's are 5s and spaces are 0s, we see repeats and we assume like, wait, what are letters that are repeated in English? Like S and E, maybe some of the other vowels, maybe like a T, maybe spaces. Even if we try to do like a shift cipher, you can still kind of have some patterns that you might be able to figure out what the message is. But all of a sudden, if I take these numbers, I multiply it by a matrix, which I can only do if I cut this up into 3s.
So it always has to be 3s?
Well, if I'm multiplying by a 3 by 3, if this was a 4 by 4, I'd have to have it go by 4s, or a 5 by 5 go by 5s. But if I multiply this by this, all of a sudden I have negatives. I can't even see the repeats. My E's that were once 5 and 5 are now negative 26 one second and 21 the next second. Multiplying by a matrix is a much harder way of coding a message because, I mean, one letter doesn't even stay the same as you go through the matrix. But here's the crazy thing. If you encode, take a message, an uncoded message, going just from the letters to the strict little like, hey, what's M, what's E, what's T? If I take a message and if I put it into numbers, and if I split those numbers into the size of the encoder, putting it into a code, encoding, and if I multiply it, the only way I can get back to my message is if I then multiply this guy by the inverse. Only the inverse can undo what has been done. And that's the whole dilemma. If a matrix doesn't have an inverse, once you encode it, there's no getting back. Your message has been lost unless you find the person who's actually knowing the message and trying to send the message. But if you have a matrix that's invertible, well, what was done that makes it look crazy with all these different numbers and negatives and positives and all this, like E changes from 1 second to the next. If you have an invertible matrix, all of that craziness can be undone back to the normal numbers that can then lead you back to the normal message. If you can just multiply back. Now check it, that's what's going on over here. We're going to take a message, and we're going to take it to numbers, using what you see right up here above. If you have a message, you can take it into numbers by just saying 0 is a space, and then A is 1, B is 2, C is 3. We're going to take a message, we're going to break it into numbers. We're going to take all of those numbers, and we're going to multiply by some sort of square matrix that is invertible. It has to be invertible or else we're in trouble. And remember, how do we know if it's invertible? You can always check and make up your own matrix. Just make sure the determinant is not 0. If it's not 0, you can use it. If it is 0, you're in trouble. Because you're going to encode it, give it to someone, and they'll never be able to get that. So you're going to take your message, you're going to multiply your message by an A. So message. Oops, I can't spell message. Also MSG. Well, let's think about that. Message times A is equal to the encoded message, so the coded message. And then if you do the coded, well, wait a minute, how do I undo?
Inverse A.
Can I write the inverse on this side?
A negative 1.
Do I have to write the inverse on that side, or does it not matter? It does matter. I can't do the inverse here and have it help, but I can do the inverse at the end. Just check it. If I do the inverse on both sides,
It just cancels it out.
it will cancel it out here, and I will, by taking the coded and multiplying by the inverse, I can get back to my original message. So, as you guys are kind of writing this down, I'm going to get my calculator off to the side. I'm going to go ahead and get this little guy into my into my calculator to show you what I mean. First of all, this A, nothing really special about him besides the fact that they just chose to use him. This message up here broken into 3 is because that was the size of my encoding matrix. So if I would go ahead and throw in my encoding matrix, which is second matrix, and if I throw in my little A, he's a little 3 by 3. Oops, sorry, edit. Bloop, 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 bloop. Okay. If this is my little encoder that I would multiply by my message, if I have this other guy and if I need him to go back, well, hold on. Where's my message? I guess I didn't put my message in, huh? My message, I would need to go ahead and take the Meet Me Monday, take the M, make it 13, take the E and make it 5. And then what size matrix, guys, would I need to make B in order for it to hold this whole thing?
3 by 3.
Nope.
6 by 6.
Nope.
4 by 3, 5 by 3.
5 by 3. I have 5 different sets of 3s. Do you guys notice that we kind of ran out at the end, and so they just started putting zeros to fill in the spot? Okay, so I need a 5 by 3. Why? Well, because that's how many letters I have, or how many characters I have. So I need to take all of these 1, 2, 3, 4, 5 different rows and throw them in. So I have my 13, I have my 5, I have my 5, I have my 20, my 0, my 13. Oh, it didn't work. There we go. Oh. Doesn't like my 13 for some reason. Thanks. We try to go fast and it doesn't like the buttons. 15, 14, 4, 1, 25, 0. What did I do wrong?
The 1 in the 4th row was 15.
Okay, so if I want to get this message and get it all encoded, I can go ahead and take my zip. I'm going to do it a little different way than the book, though. I'm going to take my message, which is my B, and I'm going to multiply it by my A. I'm going to encode it, which is the first guy. I know it's going to look even differently than that one because depending on which way you multiply it, it's going to totally change what the message looks like. But then check it, guys. If I multiply it by A inverse, all of a sudden, boop, boop, inverse button, right? I go right back to my message. And there's absolutely no other way of getting there without having the correct decoder matrix or the correct encoding matrix and finding its inverse. So, all that to say, if we were to want to take a message, if we were to want to encode it, we could technically choose any encoding matrix that we want. We would just have to make sure it's either a 2 by 2, 3 by 3, 4 by 4, that it's square. We'd have to check its determinant, make sure it's not 0. We have to make it a square. We have to make sure its determinant is not 0. And then we would have to split up our message to be the correct size as far as going by 2s or going by 3s or going by 4s. But then we could go ahead and give someone this random string of numbers that seems to have absolutely no pattern whatsoever. And either they know our encoding matrix and how to do inverses of matrices, or you give them the decoding, aka the inverse matrix, and then they can go ahead and go back to the message. But without that, there's absolutely no way that they could find a pattern. At least not very well without being some sort of crazy, you can do matrix multiplication backwards in your head, not knowing the original multiplier. Which I don't think most of us can do. So does it make sense what I've done here as far as taking a problem, taking a message? Where did all those numbers come from? Because it wasn't there to begin with. You guys can see my writing, right? Where does 8 and 5 and 12 and 16 and 0 and 9, where does all of that come from? H is the 8th letter of the alphabet. E is the 5th letter. L is the 12th letter. P is the 16th, and then there's a space. I is the 9th. Now, hold on. Why do I have these all like oddly, awkwardly segregated?
Because the encoding matrix is 2 by 2.
Because the encoded matrix is a 2 by 2. How big am I going to have to make my matrix in my calculator to encode it, to put it into code?
9 by 2.
Because I have 9 different rows of 2, right? So I'm going to have my little 9 by 2 be multiplied by that could be my matrix B, be multiplied by my little encoder, matrix A. And once I do that, I'm going to get this crazy encoded message of all these numbers that I have no idea what they mean. And the only way to get back, the only way to check that I've done it correctly is to multiply that by A inverse. And if I've done it correctly, where should I end up? Right back at my message. Now, so sad. Usually at this point, especially in honors, I have you guys pick a message of like 20 letters or less and try to encode it with a matrix. Give someone in your group the really random string of numbers with the original matrix that you used and see if they can figure out what the original message was. But as you guys can tell, how many minutes do we have left? So instead of doing that, which would have been snazzy and all, we're still going to have this homework due. That was more like a homework help. We're going to have this homework due on Monday, but Monday might be like a partial work day. We'll see how Monday goes and how the homework goes. The test is supposed to be on Tuesday. Maybe I'll budget to Wednesday because literally everyone else is having a test on Tuesday. Just kidding, but all the calculuses are. It might be nice for you guys to not have to battle calculus kids Monday afternoon if you do need help. So I'm going to make the deadline for homework Monday night. Just because if we have a partial workday Monday class, I would start and try whatever you can this weekend. But if you get stuck, don't stress. Come Monday with it. Does that sound good? We can kind of powwow. We can kind of work. People can be working on their review and spreading it out over a couple days. People can be getting tutoring hours in class. But we will start class on Monday with, think of, what message do you want to send? And you would have to make an encoder. It can be any square matrix. Just make sure its determinant's not 0. Maybe you guys could be ready to hand off your message to someone in class with random numbers. Let's say 20 or less. 20 or less. You get to choose the encoder. Just make sure its determinant's not 0. You get to put them into numbers, multiply them, have a random string of, haha, here's my message. Can you find it? Jaden.
When's the test correct?
Monday.
It was supposed to be Monday. Which if we have a work period on Monday, and the test is budged until Wednesday, we should be able to get it all in, right? I think so.
Huh?
Okay, definitely work day on Monday. Definitely test is moved to Wednesday. And if you guys were working on section 8.4 and got stuck at all, I'm going to go ahead and, in the video, the YouTube posted online, I'm scrolling through the evens that you guys could access this weekend and come with questions. Monday's a work day. But the more prepared you are for it, the better you will be able to use it. Here are the evens if you guys want to look at them this weekend.